Hi everyone, in this video I will going to solve this Nice Algebra problem. The equation we have root of t cube is equals to root of 3 cube. Here we need to find out the value of t. So let's get started the solution. The first step I will going to write this root in the form of power. So for that I will going to use the radical rule, that is n root of a can be written as a to the power of 1 over n. So here we have root is always equals to 1 over 2 power. So I'm going to write here t cube whole to the power of 1 over 2 is equals to 3 cube whole to the power of 1 over 2. Next, I will going to apply here the exponential rule, that is a to the power of m whole to the power of n can be written as a to the power of n and whole to the power of m. So here I'm going to exchange the powers. T to the power of 1 over 2 and whole to the power of 3 is equals to 3 to the power of 1 over 2 and whole to the power of 3. Now here, as we know that root is equals to raised to the power of 1 over 2. So here this I will going to write root of t and whole to the power of 3 is equals to root of 3 and whole to the power of 3. Next, I will going to take this root of 3 and whole to the power of 3 to the left hand side. Root of 3 and whole to the power of 3 minus root of 3 and whole to the power of 3. Now here I'm going to apply the algebraic identity, that is a cube minus b cube can be written as a minus b, a square plus ab plus b square. So this is our a value here and this is our b. So this equation turns to root of t minus root of 3, root of t whole to the power of 2 plus root of 3 times root of t plus root of 3 and whole to the power of 2 is equals to 0. Now here this and this get cancelled, and here I will going to apply the radical rule, that is and root of a times and root of b can be written as and root of a times b. So this will turn to root of t minus root of 3, and here I am going to write t plus root of 3t plus here this and this get cancelled, here 3 is remaining, is equals to 0. Now here we get the two cases. Root of t minus root of 3 is equals to 0. Now here I am going to take this root of 3 to the right hand side. So it will turn to positive root of 3. In the next step, I am going to raise square both the side for removing that root. Root of t whole to the power of 2 is equals to root of 3 whole to the power of 2. Here this square and root get cancelled, this and this get cancelled. So the value of t here we find out, that is 3. That is the real solution or the real root. Next, I will going to solve the second case. The second case we have t plus root of 3t plus 3 is equals to 0. Here I will going to take this root of 3t to the right hand side. So here we will get t plus 3 is equals to negative root 3t. Here I want to remove this root. So again I will going to raise square both the side. Next, I will going to apply here the algebraic identity, that is a plus b whole to the power of 2 can be written as a square plus b square plus 2ab. So this is our A and this is our B value. And here we get t square plus 2t times 3 plus 3 square is equals to, now as I'm going to square this, I will get the positive value, and here this and this get cancelled. So here we'll get that is 3t. Now next I will going to take this 3t to the left hand side. So here we get t square plus 2 times 3 give us 6t plus 9 minus 3t. Now here I will going to solve the like terms. The next expression we'll get here, t square plus 3t plus 9 is equals to 0. Now here we get the quadratic equation. The a value we have that is 1, and the b we have 3, and c we have 9. Now I'm going to plug in this ABC's value in the quadratic formula to find out the value of t. T is equals to minus b plus minus root of b square minus 4ac over 2a. T is equals to minus the b value we have 3 plus minus 3 square minus 4 and 1 and 9 over 2 and 1. T is equals to minus 3 plus minus, here we get 9 and minus 4 9 times give us 36 over 2. And now this will turn to T is equals to minus 3 plus minus root of negative 27 over 2. Now here I want to separate this negative sign from 27. So here we'll get t is equals to minus 3 plus minus root of 27 times negative 1 over 2. Now as we know that root of negative 1 is equals to iota, the imaginary number. And here we're going to write t is equals to minus 3 plus minus root 9 times 3 iota over 2. And the root of 9 we have that is t is equals to minus 3 plus minus 3 root of 3 iota over 2. So here we get the two imaginary solution, that is minus 3 positive 3 root of 3 iota over 2, and the other one I'm going to name this t2, and this is our t3 value, negative 3 root of 3 iota over 2. So here we get the two complex solution and one real solution. So this is the final answer. Thank you so very much for watching my video. If you like my video, please do hit the like button and please support my channel by subscribing it.